All right, now we're going to talk about even more introductions to proofs that are not with equations. And so this is the second section, and this will be the last one that I will explain. Section 2.4, I'm going to reiterate this at the end. Section 2.4 will be absolutely nothing new. It'll just be a second day for you to practice what we did here, okay? So because this proof thing I told you is really hard, and so I want you to be able to do that easily. Yes, ma'am?
Are we going back to the notes?
Yes, now you can go back to your note sheets. 2.3, yes, I've got you flipping through a lot of stuff. Good job. Good job. So this is more introduction that we had a precursor with all those algebra properties. Yes, ma'am.
About this.
That will be part of your assignment. Part of your assignment. Okay?
Okay.
Okay. Any other questions, Amy? That is part of 2.3. That's the proof parts. And then 2.3, and it tells you to do the proofs on the previous page for number. Okay? All right? Got it now?
Yeah.
Good. All right, here we go. Today we're going to do some proofs. I've got some things in your note sheets. We're back to the beginning of the note sheets. Not beginning, but we're at, I think, one page. You got it right there. Got it right there. All right. This is what you will use for reasons. You're going to be using your definitions, any of the definitions you might use. We did those first unit. And by the way, some of these are in fill in the blank on that, so you might want to be watching as they come up. You can use definitions and properties. Right here. Definitions and properties you can use as your reasons. That's why your properties are going to go into your postulate book. Maybe I should have called it your proof book. Now, I'm not letting you put definitions in there, but properties, postulates, theorems, you can, okay? The properties that we already discussed were the addition property, subtraction property, multiplication property. By the way, that is the symbol that mathematicians use is your asterisk. And if on your computer you're trying to multiply things, you use that. Division is the slash and your distributive. And I think there's substitution in there. Reflexive, symmetric, and transitive. Oh, wait. Let you catch up. Substitution.
What was there when you think was in there?
Substitution I didn't give you yet. You can put it in there. You can use postulates. The postulates that I know for sure that you had last chapter, were your segment addition postulate and your angle addition postulate. Those two postulates we will be using, especially on our proofs today, and your proofs that you'll be doing at home. You can use theorems. Oh, okay. All right. You have some theorems. I don't know how many theorems you have, but so far, I believe every single thing that I have sent to you here, all of those can go into your postulate book. It does not matter what order they're in, so if you put some of them in but not the others, it's not going to matter. If you want to color code things, feel free to do that. If you want to highlight the title and then put the words, if you want to put a picture next to it, no extra notes that goes with it. But if you want to highlight the titles in different colors and put pictures next to them, feel free to do that.
Do we actually have pictures that you're going to draw out for them on here?
They have some there might be some in the notes. If not, as we do some, you might see some. Okay. All right. Proofs. These are some things that all proofs have. At least the ones in geometry have. There are some things called paragraph proofs. We're not going to spend much time on those, but the proofs that we're going to be talking about are the kinds that are 2-column proofs. Proofs are in 2 columns. Okay, you might have fill in the blanks for some of those. Proofs are in back up. Proofs are in 2 columns. You number both of the sides. You've already seen that last when we were doing the other ones, you saw that we numbered both sides. That way you can tell what goes with each other. The first reason is always given. Now, I'm gonna emphasize that sometimes there are multiple givens. There are 2 pieces or 3 pieces, and you don't have to use all of them at the beginning. But you need to start out with something that's given to you when you start your proof. So you don't have to use all the pieces of the given, but you need to start with at least one of them. To make it easier, you need to mark up your diagrams. That's why all those times before in the past, I've had marks on the diagrams and I said, what's equal? Well, now we're going to go the backwards and I'm going to tell you what's equal and you need to mark up your diagrams. Sometimes you don't know even where to start. You might want to start making a list of the things you know based on what's given. That will maybe help you get to the end of your proof. I'm going to give you more tips as we go along because these aren't the only things you can do, but to start off, this is one. Some. Next, make sure you stay with me just really quick because this is something I really want. If you're ahead of me on this one, don't go on any further, okay? But if you're not here, catch up. Okay, here we go. This is a really big because some of you are perfectionists. Some of you want to do everything just right. And sometimes when you get to a proof, you're going to go, I don't know what to do. And nobody is expecting you to know what to do. That's why we're going to do a bunch of them together. When I start you out this time, they will not be a blank side here. There will be, we will not start you out with nothing over here and make you do the whole thing by yourself. I will have either all the statements given to you, and you must give the reasons, or it might be the other way around, and they might be all over on the reasons, and then you give me these to begin with, because you need experience with proofs. Proofs are a way for you to learn a way of thinking, and I'm not going to throw you into the water and make you drown. Right? That's not the purpose. Last thing here is that proofs are a way to train your brain. That's the purpose of them. You in life are going to be told things.
No, I'm sensitive. I can't take
About edit. All right, here we go. You're going to be able. You're going to be told things in your life that might not be true. If you have a process of reasoning through things that's logical and orderly, you'll be able to reason your way out of it. You're going to be able to debate with others when they tell you things that aren't true. You'll have more knowledge to be able to do that. You'll be able to challenge the opinions of others and hope maybe sway their opinions. You'll be able to justify your beliefs and what you believe based on what somebody else might believe because you have logical reasoning, okay? Many of you in here have gone further in debate than just geometry, but and then with proofs than just geometry, but all that is to help you have a logical way of thinking, all right? All right. Ready to learn proofs? I believe is to just do them, okay? And I've got it over there already, and I'm sorry it's so dark. If you guys need a pen or something to write on there a little better. All right, so remember we always have statements and reasons. On your homework, this turned out to be the statement and reason thing turned out to be kind of small. If you'll flip over to the assignment page and you'll just see, if you don't write that little, and I don't think it's that, let me see if I can see Amy's. She even printed it in blue. The little area is super teeny. If you don't want to do it that teeny, you can do it on the sides. Enable your reasons 1, 2, and 3, and so forth. Okay, I'm sorry. If there's enough, you might have to read them there, though. Yeah. Today, on this part, what I'm going to do with you, we won't be filling in any blanks. We will be doing the proof, okay? All right. I'm going to give you a diagram. Most of the time, you'll have a diagram. I will be telling you what is given and what it is we're going to prove. So I'll be telling you what's true about the diagram, and I'll be telling you what you're going to end up with. I want you to notice right now that there are no segment markers over the top because I am telling you that they are equal, and apparently geometry people, or what do you call geometers? Do you call them that? When they're equal, you don't have to tell if it's a segment or not. So that's why I don't have those little segment markings. I've made a note to myself to mark the diagram. I want you to mark right now that RI and PI are equal to each other. I want you also to know that we're not talking about congruent yet, but we're going to talk about everything in equals because you just did properties of equality, and so we're going to be talking about only with equals right now. So I'm going to get out my marker.
Mark the diagram?
Mark your diagram. Mark that Ri and Pi are equal to each other. How do we do that?
Well, I'll set that right.
That would be an angle. That would be marking an angle. How do we mark that things are equal? When I asked you to do the backwards way and you saw this diagram and you had these little marks on it, how did you know that Ri would be equal to Pi?
The line.
The little line things on there. That's right. So we're going to go Ri and Pi. There's supposed to be something else that's true. So let's add it to the bottom. Ri and Pi are equal, and It is going to be equal to IQ.
Wait, what?
Not everything got put in there.
IT.
How do we mark IT? That is so true. How do we mark IT and IQ? Now that we have one mark here and one mark here, how do I mark that this is different than that, but the same as those? Two little marks, that's correct.
Is it okay if you did it the backwards way?
Yes.
Okay.
So I'm going to make 2 on here and 2 on there, but if you made it backwards and you'd put 2 at the top and 1 at the bottom, that's not a problem. Okay. So now we're going to try to prove that something's wrong. I can't believe it. I'm sorry. That's supposed to be a T. RT is equal to PQ. Here we go.
So you said that's supposed to be an RT?
Yes, RT equal to PQ. The whole, I'm going to actually change colors here. This whole piece is equal to that whole piece. I didn't change colors, but the whole piece is equal to the whole piece. Okay? So I am going to do this with you and discuss with you and tell you how each piece works. You have no idea how to do this. You've never done this before, all right? Remember, the first step, the answer is always going to be given, right? So we're going to just write the given. The very first thing you should do is mark your diagram. We did it. Then we're going to write our pieces up here, this and this together. We're going to just write them both up there.
Wait, how do we write both of them? What do you mean?
Good. I'll show you.
Do you have like a blue?
All right, so I'm going to write Ri equals Pi. You can write a little and or a comma. You could put it underneath that It is equal to IQ.
IQ or PQ?
PQ. Thank you very much.
No. I'm starting to write ours now.
All right. So we're going to talk about this together first. We have the top piece. The top pieces are equal to each other. And the bottom pieces are equal to each other. I hope it seems logical that if we added these together and we added those together, the wholes should be equal to each other. I'm going to say that again. If this piece was 4 and that piece was 4, and this piece was 6 and that piece was 6, if I added those two together, that should be 10. And I add that together and it should be 10. So the wholes should be equal to each other, correct? All right, let's see how we can prove that. We are going to add them together. We're going to do it with letters. We're going to say that Ri plus It equals RT. What reason can we do that with? It's a postulate you guys learned already.
Addition,
Not an angle, but
Addition.
we're going to do it segment addition postulate. Okay, so let's write that out. Number 2. Pick the right thing. 2. Ri plus It I'll turn it down in a minute, equals RT. I'm going to do the other one in the same step because they're going to have the same reason, okay? This is segment addition postulate. I'm going to write that answer over here in reasons in a minute, but we're also going to do the same thing for the other one. We're going to say Pi plus IQ.
Don't write the reason yet. She hasn't given
Right,
us the reason.
you can, but I'm gonna do that in a minute. Equals the whole thing, okay? So right underneath, I'm gonna write PI plus
underneath.
IQ equals PQ.
Is that 3 or just under?
Number 2 still. I'm gonna do something to help our life be easier here. Oh no. Moving this down out of the way. So he's way over there, so it's not in the way. I'm gonna actually do the same thing on this because it's way in the way. I'm gonna make him smaller so he fits. All right, we said the reason for number 2. The reason you're gonna number them is because notice how you could write them right across, but sometimes you can't. And if we did not know, if we didn't number them, sometimes your reasons are going to be longer because it takes more words, or they're going to be shorter and you won't have room. So that's why you need to number them so we know what goes together. We said segment addition postulate, and we're going to abbreviate seg, add, prop.
Wait, prop? Is it property or postulate?
Postulate, thank you. There we go. All right, I want you to notice I have RT. That's where I'm trying to get to. Keep track of where you're trying to get to. Down here at the bottom, I have RT and PQ. That is why I wrote that RT and not backwards TR over here. I didn't write them backwards. I wanted them to be in the same order that they were over here so that when I'm done, they'll be there, okay? All right, now, we have something else. Because we have these equal to each other, I want you to notice that I have on this side, right here, I have an RI and an IT. Look up here. I have RI and IT right there. I have a PI and an IQ and a PI and an IQ right there. That's really actually going to be nice for us. This is a technique that you guys you're going to use over and over, so watch. If I have 2 things that are equal, and if I add the equal things on both sides, it will stay equal. What property is that we just learned? If I have 2 things that are equal and I add equal things on both sides, it will stay equal.
I'm lost.
Okay?
I'm lost.
We did get
About the PQ, isn't that? I thought that was supposed to be PQ, but you said IQ just a second ago, and I'm looking and I'm really confused.
this was the IQ.
No. On number 1, IT equals we have
Oh.
PQ. And on number 1.
Okay, wait. Maybe I wrote it wrong. Wait a second.
It would be IQ equals IT. Yeah.
Oh, my bad. It's supposed to. I wrote it wrong. My bad. Right here. Thank you for speaking up, Nora. That's an IQ. And this needs to be.
No. The first one.
I know. I just my eraser was too big. So PI, and it's supposed to be IQ. Please. Okay. Thank you for fixing me on that one. Politely too. Good job. My bad. It needs. Yeah. Okay. So let's do that again. I have 2 things that are equal. And I'm going to add to both sides something that are equal. And it will stay equal. You had a property that we just talked about, one of these.
It's addition, right?
Addition property of equality says, for example, when I had 3 equals 3, and I could add an A to both sides. If A's are both equal, I can add them both sides and stay equal. So, number 3 will be RI plus IT. Oh, my bad. You keep going. I just should have taken out my circles up here. These ones here, by the way. I'm adding those 2 together.
Do you put the PI plus RQ underneath it?
I'm going to go across and then I'm going to squish mine down. But if you need to do it on 2 lines because it won't fit, yes. I'm going to do PI plus IQ. This is the first time you've ever seen this. This is the addition property of equality. This says because I started off with something that was equal, I started off with something equal.
Prop.
Yes, addition property of equal. Addition property, that's right. We started off with something equal and we added something that was equal to both sides and it stayed equal. This is the addition property, okay? Number 3. Okay. Now, make sure you ask questions if you don't get it. Because this is the first time you've seen these things. I have an RI right there. An RI plus IT, and I have an RI plus IT. In the place right there, my bad, right here, what can I put in the place of RI plus IT?
RT.
Yes. Really quick. Over here, I have PI plus IQ. What can I put in its place?
PQ.
What reason can I do that?
Reason number 2?
No. Amy?
Wait.
Substitution?
Yes. Substitution. If something's equal, I can substitute in its place. We know that RI plus IT is RT, and I can substitute in. I know that PI plus IQ is PQ, and so I can substitute right in. Let me erase all those little reds and stuff. Number 4. RT equals PQ. What reason did we say?
Substitution.
This is the one you have to write all the way out. I suppose I'll let you do subst. But you have to do the ST because I can't just do sub because I won't know if it's subtraction. And we probably should put the word prop.
Wait, SUBTST.
Subst.
Substrop. I'm never gonna get 6.
All right, scoot it over a little so I can have my line. Okay, what do I do next?
We're done.
We're done, all right? This was the first time I've ever seen a proof. Some of you are going, oh my goodness, I don't think I can do this by myself. You won't have to do this by yourself. I am showing you techniques of things that you're gonna do. Now that you've seen this, hopefully you can see how an addition property might work. If I have 2 things that are equal, I can add the left sides and the right sides to each other to make one long one, okay? You know about segment addition postulate, and you know about substitution. So you've known about 3, that's 3 new things. You know, I had one student, only one in my life, maybe 2 or 3 in my life, it stood out. The very, very, very first statement is given. Is the very, very last statement proof? No, never ever, okay? So there will be a legitimate reason for the last one, never given and proof. It's not like that, okay? All right, let's try another one. I've got a diagram. You've already seen your diagram. It's now angles. I will do my best to number angles because I sympathize. I don't like to write very much. I don't like this whole thing by angle AEB. I'd rather call it angle 1. Okay? The thing is, if you need to refer to angle like that angle, you can't call it angle 1 plus 2. You're just going to have to call it angle AEC, excuse me. All right? Here is the given. We're going to mark our diagram and I'll let you mark that diagram. And notice I did have to do the angle AEC and ABED. Please mark those as congruent. We're trying to prove that angle 1 and 3 are congruent to each other. Give me a kind of this like heads up when you've marked it. Okay, here we go. I'm going to mark it, and I'm marking that that's AEC, and it is equal to BED. Those are equal to each other, and we're trying to get to the idea that angle 1 is equal to angle 3. Before you start, is there an angle that is in a piece of an angle that is in both of those?
BEC, angle 2.
Angle 2 is in both of those, okay? So, either we could subtract it out using a subtraction thing, and we'd only be left with 1 and 3, right? Maybe, I don't think division would work. So, since it's in both, that's something you need to kind of pay attention to when you're doing proofs. If there's something in both of them, there are times you're going to use that fact that it's in both of them. Okay? All right, we marked up our diagram. All right, the very first step is to write our given. number 1, angle AEC is equal to angle BED reason is given. Okay. I'm going to remark my diagram. Okay. All right. We're going to use, I'm going to do this with you and explain why. All right. I'm going to say that AEC equals angle 1 plus angle 2. What reason can I say for that one?
Addition?
What kind of addition? I'm going to say that angle AEC,
Addition property?
not addition property. Addition property says I start with 2 equal things and I can add 2 things to each side. Angle AEC equals angle 1 plus angle 2. Why do the pieces of an angle add up the whole? We did it on the last one, but we did it in segments added together. So if you want to look back to the previous one, we had 2 pieces of the segment added up to the whole.
Oh, segment addition.
So this is not segment addition, it's called angle addition. So if I said that angle AEC, that's the one down here, is angle 1 plus angle 2, what do you think I'm going to do for BED?
Angle 2 plus angle 2.
Yes, and I'm going to write that for the same thing here, angle BED. I'm going to just put it the same, since it has the same reason, I'm going to put them together. Oh my bad, I can't do that. I got to put angle for 2. Angle 2 plus angle 3. You guys said what reason was that? So what do you want to do, Amy? How do you want to abbreviate that?
And add plus.
Angle, I'm going to write, you know what? This is even cooler. Watch, Amy. You're going to love this one.
Oh.
Right, ready? I'm going to do this, angle. Angle, add, post. And I changed the color so that if I ran out into the black area, it would show up better. Okay, angle addition postulate. Number 3. All right. So, now, I wish that wouldn't, my eraser wouldn't have. I have AEC equals 1 and 2. So up here on this AEC, what could I put in the place of AEC?
Angle 1 plus angle 2.
That's true. I could put angle 1 plus angle 2. What could I put in the place of the BF? That's an F, not an F. It's an E. BED.
Angle 2 plus angle 3.
Yes. What reason can I do that? Why can I just, so I have an AEC here, substitution. So I have AEC, and I have a 1, 2, so I can just take this and stick it right in that place.
So
Take that and put it in that place. Take this and put it in that place. We said that reason was what?
substitution.
Substitution.
It's not subprop.
No,
You could. It is substitution property. You can do subprop.
It's sub.
But you have to do the ST, right?
Yeah, it's
All right. Number 4. Now, listen.
Confused.
What is in both of those? There's something on both sides of this is an equation now. There's something on both sides of that equation.
Angle 2.
Angle 2. How can I get angle 2 off using all that algebra that you used like a billion times? Subtraction property of equality. If I do subtraction, what will be left?
Angle 1 equals angle 3.
Is that what I want?
Yeah.
Yes, that is what I want. Okay, number 4, subtraction. Amy, you can use the sub this time, Amy? Okay. You could not have done this all by yourself the very first time. The technique that I want you to see is the substitution that we did. We did an angle addition postulate. We didn't do that last time. We did a segment addition postulate. And I wanted you to see that if something's in common, you can subtract it out. On your homework, I will not give you a blank proof and ask you to do it. I will be giving you maybe all the reasons and making you do the statement. I will give you all the statements and ask you to do the reasons. I might have you fill in some blanks on the reasons, the statement side, and you give the reasons. I might do the other way around and give you all the reasons and you give me the statements. I'm going to make one exception to that. Remember how I said this is a 2.3 and 2.4? You're going to have proofs both of those days. Only one proof where you have it totally blank. You're going to try your very, very, very best to do as much as you can. And we're going to come back together. There won't even be the answers for you to check. We're going to come back together.
Kill me, Mom.
And we're going to do it together to make sure you know how to do it. Yes, ma'am.
Is there one on the quiz?
Not on the quiz at all, I promise. That would be mean.
What about on the test?
On the test, I might give, it will be a while before I'll make you do a whole one by yourself. Homework is learning, you know, it's not like as bad. And we'll be talking about it together when you come back, okay? All right, questions? Right. All right. Another one? Yes. The same diagram that you had before, except different letters. M-I-S-R-N. Okay? Maybe that isn't the same one. No, you had an R there last time.
No, it was different.
It was different?
It was different.
Different letters.
All together?
Yeah, eyes in the same.
Yeah, but it's the same diagram, just different letters, right?
Yes.
All right, here's the given. And I'm going to make you mark the diagram. Mark the diagram. This time, I is the midpoint. Before we go on anywhere, if something is a midpoint, this is crucial. How do you mark that something is a midpoint?
Put an M there, right?
No. What does it mean to be a midpoint?
It's like the
intersection
center where
point.
they intersect.
But can a midpoint be anywhere?
No.
No.
It's in the middle. What do you know about each piece then if it's in the middle?
Very equal.
They're equal. So if I is the midpoint, you can mark that M, I, and I-N are equal. You will have to state that they are equal in your proof. And I'll tell you the reason when we get there, but you can mark that they're equal, all right?
Then what do you know about M, I, and R?
Good question. How do we mark? Give me some suggestions. It's going to be up to you, but give me some suggestions. How do I mark that?
Mark like a single and then a little ways apart from it, mark a double.
That's what I'm going to do. I'm going to change colors. You don't have to, but I'm going to change colors. I'm going to make a 2 there and a 2 there, so that kind of like that.
Is it okay if I did it the other way around?
Yeah, definitely. Okay. And our goal now is to make IN equal to RI. We know that these are equal. And we know that so we know the purples are equal, the oranges are equal, and we're going to try to get these lone R, purple and yellows, oranges, or whatever, be together, okay? Can anybody see, maybe think of a property that says that if these are equal and these are equal, then their cousins have to be equal.
Oh, wait.
If Joan, let's see, if Joan is cousins with Hal and Joan is cousins with transitive, we're going to try to use maybe transitive, okay? All right.
Yeah.
Did I use transitive? I did. All right.
Yeah.
Here we go. I want you to be cautious to know what direction everything's written in. I-N-R-I. Try to keep them that way. Try to put I-N first when you're going to do something and R-I second because it needs to be in the right order. If you put it backwards, you got to use symmetric to turn it around, okay? But that would be an extra step, and we all don't want to do extra steps.
So it's kind of like second semester logic then for CC.
Yes, but I'm going to lead you. I'm giving you, this would be second semester throwing you at the wolves, but in your homework it won't be as throwing you to the wolves. Okay? All right. I'm giving you the experience.
Like
yeah. All right, here we go. What do I do first?
You write the whole given.
Yep.
So.
That would be M.
Let me see something. Just like, let me see something. Yeah, I'm going to do all together. Number 1. You don't always have to write all your given at the beginning. I is midpoint.
Oh, wait, do you have to write I as at the top?
Can we write I equals midpoint since it's an equal abbreviation?
I suppose. Yeah. And some people abbreviate midpoint like this. MIDPT.
Let's just do that.
Let's just do that.
Amy.
Of, I'm not even going to say of. I'm just going to midpoint MN.
Mid. No, that doesn't work.
Okay, and then I'm going to put MI equals RI. I want you to notice we're not doing
What's the
congruence right now, but, and then I'm going to squish it down because I have that ability.
We don't have that.
I know you don't. Reason is
Given.
given.
That's a 1 over there, not a 2, by the way.
Thank you so much. We said maybe we were going to use transitive. I told you that just because with these orange little marks over here, just because you marked them, they're equal. It doesn't say they're equal in here, so we're going to have to say they're equal. So let's do that next. Number 2.
So MI equals IN?
Yes. And we want to do IN because IN is the direction of our proof. MI equals IN. We have to know the reason, though. This is the first time you've ever heard this reason. It'll be something to perk your ears up and to try to remember this reason because you're going to use it again and again. But it's the definition of what?
Definition of midpoint?
It's the definition of midpoint. You would not have been able to come up with that one on your own because this is the first time you've ever seen it. It is the definition of midpoint, okay? You didn't have, and we did that one, might have done that one last, so definition, I'm going to do DEF.
The def of mid.
Yeah, you can do that, or just def mid. I'm going to do MIDPT. Okay, and I like to make my T's curvy. All right, so now we have...
What's the... Oh, midpoint.
Mm-hmm. What's our goal? Our goal is to get...
IN.
Do we have an RI and an IN in here somewhere?
Yes.
I have an RI right there and an IN right there. And I marked it so much you can't even see it. Okay, having those two. Do I have something in both of those in common?
Yes.
An MI. So watch. MI equals RI and MI equals IN.
So that would be MI plus RI equals MI plus IN?
No, we can do even faster. We can just get to the number 3 and be done.
Oh, we can?
We can.
Oh, yeah, by transitive.
Yes. We know, if you remember back, look at transitive. Transitive says if A equals B and B equals C, then A equals C. And that's what we have. We have B's in both of them. Okay, B's in both of them. So we can just, instead of going through B, we can just jump to the A equals C. We have that right here. We have MI equals RI, and we have MI equals IN. So we can just jump, skip the middle step to just do the RI. Now, I'm gonna also show you that we could have used a different reason, but let's do it. We're gonna do MI. Is it MI? IN. Excuse me. IN, and write it how it's put in your proof. And my notes paper, I wrote it backwards and then had to do something else to get it back. Equals RI.
Put trans property.
Transprop. Yep, transprop will work too. Now, I have used these two, transitive and another one, like almost interchangeably at times. Okay? Not always can you use this other one in place of transitive, but sometimes. But I could have just picked up, and I knew what MI was, and I could have picked up the IN and put it in the place of MI. What reason is that one? If you in a sense, pick up that one and put it in its place. Substitution. Right? So there are going to be times when transitive is the same as substitution. So you could have used substitution, transitive in this place if you wanted to. All right? It would have been fine. There's times when transitive works better when there's just small 3 things. Substitution works when you have this big long sentence and you're plugging things in, okay? But transitive and substitution can be sometimes interchanged. All right. We did a ton with proofs, and I could have scared some of you some major time. I hope I didn't scare you too much. Let's look at, I'm going to reiterate what we talked about. All right. On your homework, you will be You will only supply the reasons. The statements will be supplied for you. And notice I have most of the time. Right. Most of the time. There will be only one that you will be doing that all by yourself. I want you to try to do it by yourself. I'm not even going to help the person that lives with me, okay? That person will be doing it all by themselves. What I'd like to do when we get, not this week, but the next, I want to try to get it so that you guys can confer with each other during the week, either by phone, by maybe a FaceTime of some kind, where you guys can say, man, I don't understand this one step. Can you help me with that? I got this and that. Proofs especially need dialogue, all right? I'm going to try to figure out with your parents how to let that happen. We will be going over it together in class when you come back. Your 2.4 assignment will have nothing new. It's just practice on proofs again. Proofs are not easy. I'm going to reiterate that again, and so we will not be going too fast. So that's why we're going to 2.4, even though it's another section, it's just the same stuff again, so that you can. And we took the whole class period anyway to do those two, right? Okay. It's actually perfect in timing. We're done.